Welcome to 5-7. Let's start with a crash course on how to evaluate the inverse trig functions. First, I want to convince you why we're doing that. So take a look at this picture here. This is a function that assigns a name to each dog. And so if I want to go backwards and I'm at this red dog, I don't know whether to go to Edison or Spaghetti as a name. So what I can do is just make my domain smaller. I can take Spaghetti out of the domain, and then I know exactly where to go back to when I'm at the red dog. I go to Edison. So the trig functions are similar. They're highly non-one-to-one, so we restrict their domains in order to get an inverse. And what we end up with is this chart here. So let's apply this definition to the problem down here. Y equals sine inverse of negative root 3 over 2. So using what's in the red box, I write sine y, so this is equivalent to, if and only if, the sine of y is negative root 3 over 2, and the important part is that y has to be an angle between negative pi over 2 and pi over 2. And that way we're going to only get one answer. In fact, we're going to get y equals negative pi over 3. Now, of course, you can do these in your head. You should probably write it out the first few times, but then you should be comfortable just evaluating inverse trig functions in your head. Okay, here are the derivatives of inverse trig functions. You do have to memorize them. I've got the proof of the first one on the last page. And notice that the second column just has a negative sign in all the numerators corresponding to the first column. So really, you just have to memorize the first column. All right, let's find a derivative. Y equals sine inverse of 3x to the fourth. So y prime is, I'm using the red box over here. We want u prime on top. Now, in this case, u of x is the function 3x to the fourth. And in all those formulas, wherever you see a u prime or a u, that stands for u of x. So on top, I want u prime. That's 12x cubed. And on the bottom, I want the square root of 1 minus 3x to the fourth quantity squared. And that's all under the square root. Okay, and then we'll just clean that up a little. 12x cubed over the square root of 1 minus 9x to the 8. Multiply the exponents. All right, and there it is. Let's do one more. Tangent inverse, now my u is e to the 2x. So y prime is, I want the derivative of e to the 2x on top, 2e to the 2x. And on the bottom, I want 1 plus e to the 2x quantity squared. And simplify that, that's 2e to the 2x over 1 plus e to the 4x. And that's it. Pretty easy. All right, now let's talk integrals. These are the three integrals that loosely correspond to the derivatives on the previous page. Notice that the only one without a 1 over k out front is sine, so that can help you with your memorization. Let's just jump right in and finish up here. This first one, we can directly use this formula. We don't have to do anything because it's in the right format, and our k is 5. So this is equal to 1/5 tangent inverse of x over 5 between negative 5 and 5 root 3. Okay, and that's, I'm going to factor out the 1/5 tangent inverse of, when I put in the top limit, I get root 3 minus tangent inverse. When I put in the bottom limit, I get negative 1. All right, now we're evaluating inverse trig functions. So using those rules I showed you on the first page, this is 1/5. Tangent inverse of root 3 is pi over 3, and subtract tangent inverse of negative 1, which is negative pi over 4. And so we get 7 pi over 60 after we get a common denominator and add those two fractions. All right, let's do one more. Now, we want to use the formula for sine inverse because this function looks closest to that one. However, we have a problem because of this 4. The coefficient of the variable has to be 1 to use those formulas. So, no worries, we'll do a u sub. We're going to let u equal 2y, du is 2 dy, and so 1/2 du is dy. All right, and now we're ready to substitute. This integral is equal to, I'm going to put my 1/2 out front, and then on top I've got 1, and on the bottom I have the square root of 36 minus u squared, and that's why I made that substitution. And then this is a du. Now we can use the formula in the red box. So this is 1/2. My k is 6, but I don't pull out a 1 over k. I just go sine inverse of u over 6 plus c. And then let's go back to x's. Since this is an indefinite integral, this is sine inverse of 2y over 6 plus c. And finally, one more simplification. That's 1/2 sine inverse of y over 3 plus C. So these are pretty fun, straightforward, easy problems. And that's the end.